Recording. All right, folks, 9.2 constructors. Now, remember, we're talking about inheritance, where you have a superclass and a subclass. We did this on Tuesday. So constructors are not inherited, but all the other stuff is. The private variables and all the public methods, all those things are inherited, but constructors are not. So that means most of the time in a subclass, you're going to write a new constructor. And because you can't access variables in the superclass directly, and I'll show you examples of what I mean, we can and often will call the superclass constructor using this super call, and it has to be the first line of the child class. So you remember last time I talked about, well, what if we had a book class and then we wanted to extend it with this graphic novel class? Well, I'm just writing a little bit of code here. This is a possible constructor for the graphic novel class. So notice when you want to create a graphic novel, you send over a title, an author, and an illustrator. And then what we're doing right here, this is the new thing. The very first line in a subclass or child constructor can be the super call. So right here, I'm calling super with title and author. And what that does is it goes to the book class and creates, it fills in the variables for title and author, because, you know, the book constructor only knew about title and author. So it's like, oh, I'm creating a book, but then it hands it back to graphic novel, and then graphic novel goes ahead and throws in the illustrator. That's the variable that the graphic novel has. So you don't have to do a super call in a child class, but if you do it, it has to be the first line in the child's constructor. If you don't put one in, here it is. If you don't do it, then an invisible no argument super call is made before anything else happens. And I'll show you. I've got a little. I've got an example here. So we'll take a look. Hopefully it loads. Okay, so I've got, I think I give you this REPL with the notes slide deck. Okay, let's take a look. I made a class called class A. It has a private integer num, and here's its constructor. When you make a class A object, it prints out which constructor got used. There's a constructor that is a no argument constructor right here, and there's a constructor that takes an integer as a number. So that means you could create a class A object with empty parens, or you could send over a number. Either one will work, and the class A object will get created. So I'm going to run the code here, right? I have text that says, hey, I'm creating a no argument class A object. Hopefully, yeah, I think REPL is just having a bad day today. Because of its switchover, it's probably just freaking out the whole world. Earlier today, it was working just great. So, but all right, here we go. So when I create a class A object, I didn't even print the object. I just created it, and it ran this constructor right here, which prints out, hey, we got the no argument constructor. Okay, so I want to show you the class B. Class B extends class A. And when we're going to create a class B object with a no argument constructor. And you would think we would just get this printout here where it says, hey, I'm doing the no argument constructor for B, but you'll see in just a sec, it's going to be a little bit different than that. So I'm uncommenting my code here where I'm creating a class B object. So, and we'll have to wait. It's good. It's like Zen programming. You have to just take a deep breath. look out the window. There we go. All right, so look what happens when we create a no argument class B objects. That's this sign right here, class B equals new class B. Comes down here. You would think it's going to just run this constructor right here. The no argument constructor in B executes. But look what got printed over here. It says the no argument constructor in A executes. That happened first. That's because in a subclass, if you don't call a supercall, Java is basically doing it for you. So me writing the word super here is the same as having nothing there. Super with empty parentheses is going to do exactly the same output. When you create a child class, you can either call the parent class with a super call as the first line in your constructor, or you can not do it, and it's going to call a no argument super call as the first line of the constructor. So basically, me adding the word super here is exactly the same as not having the word super there. I'm just proving it by running it. Mostly, like, you wouldn't usually put super with nothing in it as the first line, because it's going to happen automatically, right? You don't need to have super there because that's what's going to happen. I guess the last thing I did was I created a class B object where I'm sending over a number, and this one, you'll see it's going to call the no argument A constructor, because see down here, we don't call super with the integer n. So it's gonna call this one, and that'll get printed, and then it's gonna print that. So I mean, this is yeah, this code is going to be in with the slide deck. So you'll have access to it in just a few minutes. Okay, so it says here, creating a class B object with an argument, but look, the no argument constructor in A executes. So that's because, right, and then the one argument constructor in B executes. So you would think, oh, it's just going to print this line right here because I'm calling it with a number, but right here, it's like there's a super call with nothing in it. So it calls the parent class constructor automatically when you don't do it by hand. Okay, so that's let's be honest. It's a little obscure, but it's going to be okay. So I'm giving you another example. So in a child class, I'm just restating it. Super is called invisibly if you don't explicitly put a super call as the first line of a constructor. So so these two constructors, let's say this is in a child class of some kind. These are exactly the same. Putting that super with nothing in it is like putting nothing there at all, because Java is like, okay, I'm going to create a thing. I know it's a child. I'm going to call the parent constructor. And in fact, you can have a whole chain of parent constructors that get called all invisibly in the background. Okay, so then I watched all the videos for 9.2 through 9.6 the last couple of days, and I'd recommend them. They're good. This was a problem from a little multiple choice problem from the 9.2 video. There's the guy who did the problem. So let's take a look. We've got a sports car class, which extends the car class. So the car class is over here in blue. You got a model and a year. You can call, you can create a car without sending any arguments, and it creates a car with an unknown model name and a 0 year, and then you can call it with a model and a year, or it's not year. Oh, that's inconsistent. It should be miles, not the year. Anyway, so then we're looking at the sports car. It extends it and it adds a color and a speed. Okay, so the question is, which of the following would be appropriate constructors for the sports car class? So you look at it for a minute. There's more than one right answer. So we're trying to identify a constructor for the sports car class. All right, I'm going to walk through them. Let's look at A. A would definitely be an appropriate constructor. It calls super with no arguments. That goes ahead and creates unknown with 0 miles. And then it sets the local variables, max speed to MS, and it sets the color to C. So that works great. Now B is almost the same. It just doesn't have the super call, but it's totally fine for B. If you don't put a super call in there, then it's going to go ahead and call it with empty parentheses. So B is also just fine. Super gets called, the object gets created with this unknown and the 0, and then it sets max speed to 120 miles an hour and says it's a blue car. So that's fine. Now C, notice we have a super call where we're sending the model and the year up to the parent. C is fine also. So this is, again, another way to do this. You call the parent with some parameters. It sets those parameters. And then when it gets down to when it comes back, it sets max speed and color to color. And then D is not okay, because if we're in sports car, we don't have access to the string model or the integer year. You can't say model equals mod, year equals Y. Those variables exist and they're part of the sports car, but you can't access them directly. You'd have to use like a mutator method that the car class would have to have a set model and set year method, and they don't, so we don't get to do that. Okay, any questions on this? I understand it's probably kind of scary, but we'll do some practice.
Yeah. So can you go back a slide to see? So it says super mod Y, but it also asks for that in the constructor. So
right. So when you call a sports car and you send it a model, a year, a max speed, and a string, it'll execute this one, and it first calls the parent with model and year, and then it sets the local its own variables.
So like in this case, would it just call from the empty car class? So the model would be unknown, the miles would be 0.
Well, in the case of C, the model would be whatever you send it. Assuming somebody called this constructor, you would have had Prius 2012, 40 miles an hour, white. My Prius can go more than 40 miles an hour, but no, it wouldn't be empty, because if for this constructor to execute, somebody would have had to send a string and a year. The first two, A and B, both of those would be unknown and 0 for the year or the miles or whatever. And I apologize, I didn't notice that this problem had an inconsistency with the year and the model, whatever, miles. Who knows what they were trying to do, but I was just trying not to recreate an entire universe just so we could do a little practice. Yeah. Yeah, somebody just told me, yeah, I got to put the Prius in power mode if I really want to get going. Okay, listen, we're going to keep going. You're going to get to practice this. 9.3, overriding methods. Now, we've already learned about overloading methods. So there's, it seems like it's almost exactly the same thing, but it's called overriding methods. So let's just talk about this. Subclasses inherit all public methods from their superclass. And we have 3 ways we can deal with things. And I've got bullet points here. If you inherit the methods, and that happens automatically. So all the methods that the parent has, the child has. So you create a child object like graphic novel, and if there's one called proofread, you could proofread a graphic novel, even though that method lives up in the parent. Okay. Another option is you can write new methods. So the children can have as many new methods as you want or need. You can even overload methods. Overloading is when you have the same name, but it has a different signature. You know, like how kind of like what we were just looking at, those constructors, where you have a constructor that can take no arguments or multiple arguments. That's the signature. An example of that would be substring in the string class. We haven't written that method, but you can call substring with 2 numbers and you can call substring with 1 number, right? Either way, that's method overloading. The other, then the new thing is overriding, and that's in a child class. You can create a method that has exactly the same name and exactly the same signature as a method in the parent class. And when you do that, only the one in the subclass will be executed. It makes sense. And we often override methods in subclasses. And I'll show you an example. Hang on, my dog is scratching to get out. So let's take a look. And in fact, this is an example of the most commonly overridden method that I think we'll use all year. The most commonly overridden method is toString. So here I have a class book where I have variables and a constructor not shown. And then the toString up top here is return title plus comma author. So it has the title of the book, comma, and then author. And then class graphic novel extends book. I'm like, no, this is just bad. This is totally wrong. Would not work. I'm gonna fix that. Thank goodness. Yeah, the graphic novel doesn't have access to the words title and author. So, but let's just say I'm overriding the method here in graphic novel, public string toString. And instead of returning the title and the author, I'm returning illustrated by Illustrator. So this is called overriding a method. The method has the same signature, public string toString with nothing in the parentheses, and public string toString, nothing in the parentheses. I have another example, but I will say we learned about overloading methods in the fall, and you know, no big deal. More than one method with the same name. Java figures out which one to run based on the parameters. Method overriding happens only with inheritance, and that's when it's the same signature as a method in the parent class, and then only the child method will run. Okay, so I'm not even going to take questions because you're going to see another example that's better right here. So the last notes for today are the super keyword. So we saw the super keyword when you could use it in a constructor to call the parent constructor. You can also use this super keyword to call a parent method. So you might, in particular, if you might need to call a parent method for a method that you're overriding in the child. So I've got the graphic novel example again. This is a much better example. So take a look. Class book hasn't changed. This toString, it returns title and author. But down here, because I wanted the title and the author and not just illustrated by, I make this call right here, super.toString. And that tells Java, go get the toString from the parent and hand it to me. And then we're going to add to it, illustrated by the illustrator. So, so we've learned two ways you can use this super call today. One is to invoke the parent constructor, and the other, along with a method, will invoke the parent's method that was overridden in the child. If the method wasn't overridden in the child, you don't need to put the word super in front of it. But in this case, toString is overridden. This is exactly the same. Like if we just call, if we tried to print a graphic novel, it would only run this code. It wouldn't run the parent code. But because we say super.toString, it goes up, gets that stuff from there, and then comes down and finishes the job. So, so you can use the super to call parent methods with or without parameters as appropriate for whatever method you're choosing. Okay, so here's another great, hopefully more internally consistent problem. So let's read this problem. We've got a car class and we've got an electric car class that extends the car. And a car keeps track of the mileage that it has been driven. And the electric car has a battery. So which of the following would be an appropriate implementation of the drive method in the electric car class? This is perfect. My dog wants back in. I want you to look at it while I'm doing that. So the key here is for an electric car, we need to keep track of the mileage, which was something the parent was already doing. And we also need to keep track of the battery usage. So let's take a look at A. A says battery equals battery minus, this, obviously this is the right formula because all four answers have this, but it's the number of miles divided by 4. It's going to take away one point from the battery charge. The problem with A is we're writing the drive method in electric car. So we don't have access to mileage. You can't say mileage plus equals M because mileage is a private variable in the car class. So A is not good. Let's look at B. B, again, we're trying to write the method here in the electric car. B subtracts the battery based on the miles, and then it calls the parent drive class with M. And the parent drive class right up here adds the mileage. Yeah, that looks great. I think that's the right answer. Let's look at C. What's wrong with C? C says super M. You can't call super M. Like if you're going to call super with something in it, that's when you're calling it as part of a constructor. And this isn't a constructor. This is the drive method. So C is not good. And then D doesn't work because you call super and then drive with empty parentheses. Look, there's no drive method in the parent class with no integer. So anyway, the right answer is B. It takes care of the battery, which is the local electric car variable, and then it calls the parent drive method with the miles, and that takes care of the mileage. Any questions while this is still showing? I mean, I agree. If you're feeling like, wow, this is a little scary, it's far less scary in practice. Okay, so for the rest of today, try to finish the warm-up. And then I've got something I'm calling quick practice, which is not a huge assignment. It does have it does not have that class A, B thing that I said would be there, but I will add it in a minute. And then we have an assignment called a store where you're going to create a little hierarchy of of products that get sold in a store. So do the quick practice first. I mean, it's not, it's a quicker problem. And then the store one is a meatier problem. And in my video for the quick practice, it only took 4 minutes. So, and I'll find that A/B thing that I said I would have, and I'll give it to you. Oh, here it is. And I apologize if REPL is, you know, acting up today. Just do the best you can. If it's not working and you can't get something done, then just leave me a note, and I won't take points off if you have to do it late. All right, I did just add the notes helper REPL to the slide deck quick practice one. And sorry, I know it interrupts you when I screen share again, but I was thinking I'll walk you through the quick practice. So read through what I'm asking for the quick practice, and then scroll down to the very bottom and write a square class. Say that it extends the shape class. So the square class has one double variable called side, has one constructor which takes the side length and the color, and it has to use the super call to set the color. So private side, then a constructor takes the side length and then the color. So here's where we can't just say color equals C, because color isn't in the square class, it's in the shape class. So we say super C, and that calls the constructor in the parent class and sets the color to C. And then we say side equals S. We are allowed to do that part here because it's right here in the square class. I think at this point we can run the code and we get pink shape and yellow shape. So it doesn't say the second thing is a square. I mean, two shapes. So then I want you to write a toString that that prints out that. I'm just bringing it down. So remember, it doesn't print it, it just returns that string. So we can't put the variable color here. Because color is a private variable in the shape class. Also, it helps if you put a semicolon on the line. So you may not be able to see it, but over here on mine, it's complaining that color has private access in shape. So what we can do, you look up here, there is a get color method in the shape class, and we can just call that. So we literally just say get color with open and closed parens. That gets the color from the parent. We could say super.getColor, I'm pretty sure, but you don't have to. Yeah. You don't have to say super because it knows it's a child and it goes and looks for it somewhere in the hierarchy and it finds it and it does what it needs to do. Oh, and I forgot a space before the word size. So, all right. Well, that's the whole square class. That's all I was looking for. If you have any questions, you let me know. We got a half hour to go. Folks, I'll be right back. Sorry.